Hello guys, welcome to today's video. Today we are going to start with the next chapter in our syllabus, that is acid, bases and salts. We have completed chemical bonding. So if you have not seen the videos yet, you can go and check the videos on the channel. So let us begin today with acids, bases and salts. In this video we will be discussing about acids. The very first thing that you need to know in this chapter is what exactly is an indicator, because indicators will be coming later. So first thing you need to know is what exactly is an indicator. What do I mean by the word indicator? By this word itself you can understand that it indicates something. What does it indicate? It indicates the nature of the solution. Indicates what? Indicates the nature of the solution. So indicates what? Nature of solution. Nature of solution. What solution? The solution that you are testing. It will show you the nature of the solution that you are testing. Okay, how? By a sharp change in color. Sharp change in color. So indicator is basically going to show the nature of the solution by a sharp change in color. Example, litmus. You put an acid, it will turn to red. You put it base, it will turn to blue. So this is a color change. So litmus is an indicator. Litmus is an indicator. So similarly, litmus is not only the one indicator, there is many other indicators which will be coming to us slightly. Okay. So this first thing is indicator. So the definition of indicator must have these 2 points: nature of the solution and sharp change in color. Okay. Next, let us learn about the first main thing, that is Lavoisier, Davy findings. Okay, Lavoisier, Davy findings. Don't say it as theory because it was not proved that time. So it's Lavoisier, Davy findings. What did Lavoisier and Davy say? Lavoisier and Davy said that all acids they will have hydrogen as H plus, that is a proton. He said that all acids will have to have hydrogen. It will have hydrogen in what format? In H plus format. Okay, in H plus format, H has to be present in acids according to Lavoisier, Davy. Clear? This was what they said about acids. What did they say about base? They said that bases are either metallic oxides. They said that bases are either metallic oxides, or what are they? They can be metallic hydroxide. They can be metallic hydroxide. Or what can be there? They can be ammonium. You know, ammonia, it is acting as a base. Okay, so they also say that it can be an ammonia solution. Clear? Because you already know that ammonium hydroxide, ammonium chloride, they are all bases, right? So these are all bases. Ammonium chloride is basically a salt formation. Okay, so these are the 3 things that they say. They said these 3 things. Is it clear? Metallic oxide, metallic hydroxide, ammonia solution. Done. They also said something about salts. What did they say about salts? They said that salts are chemical compounds. They are chemical compounds formed by the replacement of this H plus ion by this metallic oxide or by hydroxide ion. Okay, metallic oxide ion, that is basically the metallic ion. Okay, by metallic ion or ammonium ion. By either of this it will be getting replaced. Then it is said to be a salt. So these are the 3 findings of Lavoisier, Davy. This is the first important part that you need to read from this chapter. The very first important part. Lavoisier, Davy findings. Next, let us move on to acids. Acids, they are basically a compound. Okay, they are basically a compound. They cannot be an element, definitely you can understand that. So we can specify here compounds. Acids. They are compound that everyone knows. They are compounds. But what is the difference between acid base? Don't say declaration right now, that is different. Acids, they will be chemical compound containing one or more hydrogen atoms. Okay, one or more hydrogen atoms. One or more hydrogen atoms. They're fine, they're containing one or more hydrogen. But the main keyword is H3O positive ion. As the only positive ion released, as the only positive ion released, as the only positive ion released upon dissolving in water, understood? So basically acid is a compound containing one or more hydrogen atom, fine, accepted. But what is the main thing? Main thing is this: H2O positive ion is the only positive ion that will be released when it is dissolved in water. So when it is dissolved in water, H2O positive is going to be the only positive ion that is released. A very important keyword that you need to remember from here. This H3O positive ion. Need to write this in your answers. Okay. Example, for example, let us write HCl. What happens if we add H2O? Why does it not gas? Okay. So it will dissociate to form H plus Cl minus. I will say that we have told H2O positive. Then what is this sum? This H plus is a very unstable compound. So what happens? It reacts with water and it forms H3O positive. Okay, H3O positive. Basically H2O positive and H plus is told to be same, but we use H2O positive. Okay, H plus is the proton format. We should have used that, but we used this. Okay, more or less the same thing, but try to write this in your answers. Okay, this is hydrogen. I already done the structure in coordinate compounds. Okay, so this is basically the definition of acids. The basic definition of acids is this. Two things are there in your answer which you need to remember when you are writing. Okay, now whatever acid you take, hydrogen is common. Whatever acid you take, hydrogen is common. I am not talking about Lewis acid. They do not have hydrogen. Okay, these acids, they have hydrogen as their element. Okay, they will have to have. Okay, next thing is, that is the classification of acids. Classification of acids. Now we have classified acids into organic. This is classification based on source. Okay, classification based on source. Organic, inorganic. We have an entire branch of chemistry on organic chemistry, inorganic chemistry. Okay, organic, inorganic. Organic characteristic is carbon has to be present. Organic means carbon. Then what else can be the characteristic? Weak acids. Okay, they are weak acids. Strength we are coming later. Okay, we will classify that as weak and strong in the basis of strength. Now we are classifying it as the basis of source. So organic has to contain carbon and they will be weak acids. They are going to be weak acids. What else? The most important characteristic obtained from living organisms, especially plants. Obtained from living organisms. Obtained from living organisms. Okay. These are the three characteristics that you need to remember from organic acids. Weak acids obtained from living organisms and carbon atom has to be present. Has to be present. Okay. Now let us discuss about inorganic acids. Before moving on to inorganic acid, let me tell some example of organic acids. So organic acids example, you can write it as CH3COOH. This you already know. This will dissociate into acetate ion. So this is a weak acid, right? So this is a weak acid. What is this acid called? Acetic acid. This acid is called acetic acid. Okay. If you go by IUPAC, then it is ethanoic acid. Here it is acetic acid. Okay. Rest more acids are there. Formic acid is there. Then oxalic acid is there, tartaric is there, a lot of things are there. So one example I am giving, that is acetic acid. Okay. Now is the inorganic acids. Inorganic acids. opposite characteristics of what organic was? Inorganic. Okay. First characteristic, carbon not there. Exception. Carbon not there. Exception. H2CO3. Carbon present? Yes. There carbon is present. Okay. Prepared synthetically. Okay. This also has got some limitations, so we will write mostly. We will use a word mostly. Okay. Mostly prepared synthetically. That means we will be preparing it. Synthetic acids. Okay. They are mineral acids. This is also called mineral acids. Okay. Mostly they are prepared by synthesis. That means they are synthesized. And some are also obtained from minerals. Clear? Mostly prepared by synthetically and obtained from minerals. That is why we have given the name mineral acids. Right? So they are prepared synthetically and obtained from minerals. Next, synthetically we have prepared, that means we will not definitely prepare weak acids, so we will prepare strong acids. Strong acids. Exception lies again here, H2CO3. Clear? Strong acid, H2CO3 is a very weak acid. Then carbon atom not present in case of inorganic acid. H2CO3 has carbon atom present. So this is the exception. H2CO3 is a big exception. That this exception you have to remember. Often question might come odd one out, suddenly H2CO3 is given in between. Then you have to check for the exception. Okay. Organic, inorganic acids, clear? Okay. Now a very short thing, that is hydracids and oxyacids. What are hydracids? What are oxyacids? Hydracids, oxyacids. By the term itself you could have understood that oxyacid had got something to do with oxygen. Okay, so these acids are basically the acids that have oxygen as a component. H2SO4, oxygen. Then you have is H2CO3, oxygen. So the acids that have got oxygen as a constituent is said to be an oxyacid. So hydrogen will be there, hydrogen and oxygen as a non-metallic element, it is said to be oxyacids. And what will be the hydracids? Is very clear. Hydracids will be, hydrogen will be present, okay, hydrogen will be present, along with hydrogen some other element other than oxygen is present. Other than oxygen, some other non-metal is present. In that case, we will be saying it as hydracids. Spelling, very careful. What is the spelling? Hydracids. Do not write the spelling as hydra acids. This double A should not come. Single A is there. Hydracids. Okay? Okay. So this is the oxyacid hydracid concept. Now let us move on to the most important thing, that is the basicity of an acid. Basicity of an acid. Basicity. This is confusing. For a base we use the term acidity, and for the term acid we use the term basicity. What exactly is basicity? Basicity, first let us learn the spelling. B-A-S-I, basicity. Okay, it is not B-A-S-C-I-C-I-T-Y. No, not basicity. It's basicity. Clear? So on this basicity, we have divided the acids into three types: mono, di, tri. Okay, mono, di, tri. First, let's learn basicity. What is basicity? Basicity is the number of ionizable hydrogen atoms per molecule. Ionization. You don't understand. See, H3O positive ions are produced. H3O positive ions are produced. H3O positive ion, how many are produced? Per molecule ionization of an acid is called basicity of an acid. Suppose HCl is there. HCl plus H2O forms H3O positive plus Cl negative. Done. Okay, check. According to Avogadro law, this is 1 mole, this is 1 mole, this is 1 mole, 1 mole. So I'm not writing all that. Okay. So according to basicity, one molecule will produce how many H2O plus and is the basicity. So here we are considering this as a one molecule. How much will it produce? How much will it produce? 1. So if 1 is producing 1, then what is it? Monobasic acid. So HCl is a monobasic acid. Okay. Ignore the mole part. Ignore the mole part because mole is not doing the syllabus right now. Ignore the mole part. Okay. So HCl, H2O, H2O plus. How many molecules? 1 molecule. How many molecule over here? 1. How many? Sorry, iron. How many iron? 1. So 1 molecule produces 1 iron. So number of hydronium ions or hydrogen positive ions produced by ionization of 1 molecule of that acid in its aqueous solution. Very important. Aqueous solution. Aqueous solution. What has to be mentioned? Why? HCl dry. If it is a dry HCl, then will it show this characteristic? No. That is why you have a question. HCl in dry state will not change the litmus paper to red. But if you add water, moist litmus paper, it will turn red. Why? Because HCl in presence of water only can dissociate. If water is not there, it cannot show its acidic property. As a result, litmus paper will not turn red. Important question. Litmus paper does not turn red for a dry HCl gas, but it turns red for a moist HCl gas. Why? Because the reason is same. Water presence, this shows. Upon no water presence, nothing shows. Okay. This is monobasic acid. So monobasic acid is basically one hydronium ion produced by replacing one hydrogen ion is produced upon ionization of one molecule of that acid in aqueous solution. Done. Dibasic, 2 hydronium ions. Tribasic, 3 hydronium ions. Now let us do some reactions. HCl I have already shown. Okay. Suppose let us take Na. Let us not take anything. So let us take HCl, right? So let us add HCl. Okay. So let us take is NaOH. Clear? NaCl will not work. NaOH. So NaCl will be formed, which is acid base neutralization reaction. So NaCl plus H2. Done. Complete dissociation done. One step. Can anything further be done? No. Done. All done. So this is one step dissociation. So this is again monobasic. Done. If it is told to you to prove that HCl is a monobasic acid, at that case you have to show the dissociation reaction, not this. This is an example. I just given an example. This is the example. Okay. Do not write this. If the question is asked, prove that hydrochloric acid is a monobasic acid, then in that case you have to show the dissociation reaction like I have already shown previously. HCl plus H2O forms H3O positive plus Cl negative. Further reaction cannot proceed, so one step dissociation. What is it? Monobasic acid. Clear? So this reaction I have to show if it is asked. Next, sulfuric acid. Next let us do sulfuric acid. So sulfuric acid will not dissociate in one step, but you can write it in one step. First let me show the one step reaction. That is if you add HCl, 2 H2SO4 to 2 NaOH, temperature is greater than 200 degrees Celsius, they will form Na2SO4. Okay, plus H2O. This H2O will become 2. Okay, so this is I have shown in one step dissociation upon balancing. Now how exactly is happening? Temperature needs to be greater than 200 degrees Celsius. Now let us see the dissociation reaction first. H2SO4, first step dissociation plus H2O added, what will happen? H3O positive released. What is remaining? C first. See what is remaining. H2 was there, 1H has been released out. This is H plus actually. So 1H has been, what is remaining? 1H remaining, SO4 remaining, charge goes minus. Clear? Charge goes minus, charge now decrease, positive charge decrease. So there is net negative charge is there. Net negative charge will develop, one net negative charge. Why? 2 negative, 2 positive, 1 positive gone. So 1 negative will develop, right? Okay. Second step dissociation, HSO4 minus plus H2O. This is the important thing. You will not write this again over here. This will become the product, the reactant for the next equation. So HSO4 minus and very important, plus H2O will give you H3O positive. Now only one H was remaining, that is also gone. What is remaining? SO4 minus, that is not possible. So SO4 2 minus. Done. So second step reaction done. Now when we are combining the reaction, we are writing 2H2O positive. Okay. That is when we combine, we can directly write 2H2O positive plus this. Okay. This will not go to this will cancel. This will get added. This will get this will write this and this will get cancelled. This will become 2 and this will become remaining. Clear? This and this will add up to 2H2O. This and this will be there. This and this will get cut. It will be ready. Clear? That is how you have to show the dissociation reaction. Okay. Now in example how to write. Example how to write. Might be given question below 200, above 200. That you have to understand. Whenever temperature is below 200, I am writing Na2 plus H2SO4. Temperature is told below 200 degrees. What will you form? NaHSO4 plus H2. Now understand what type of salt is formed. Acha. Types of salts. That we have a separate part. But I am just saying it for acid also needs to be said that. Acha. Is there any hydrogen? No. Is there any OH minus? No. H plus is also not there. OH minus is also not there. That means nothing of the base is there. Nothing of the acid is there. Nothing is there. So it's a neutral salt. Clear? So monobasic acid will always have to produce a neutral salt. It cannot produce any other salt. Okay. Now see for this reaction. This is below 200 degrees Celsius. Okay. Is there any H plus? Yes. See, H plus is there. This H plus is located over here. So H plus is present. That indicates that it has got some acidic character. So this salt is neutral salt, but this salt is not neutral. What type of salt it is? Acid salt. Clear? So whenever there is a dibasic acid, it will produce one acid salt, one neutral salt. Neutral salt will be one. Only one for every case. Okay? For dibasic it is one neutral, one acid. For tribasic it is two acid, one neutral. Clear? Okay. Now for the second step, when this temperature goes above 200 degrees Celsius, whenever it's above 200 degrees, what will happen? This H will not be there. Instead what will be formed? Na2SO4. And you can very well understand that that becomes a neutral salt. So one neutral salt, one acid salt. Clear? Okay. So here we will write 2NaOH. Here it will become 2. Clear? That's the reaction. This is dibasic acid. Okay. Now let us see for the tribasic acid. Okay. Now let me tell you an important thing for moving on to tribasic acid. Often people see the marks and give. Marks, I mean by marks is, suppose the acid is this. People see this and give. Mostly it will get correct, but sometime you might go wrong. Some cases you might go wrong. So do not judge by seeing this. Okay. Do not judge by seeing this. Instead go for the reaction when you are doing. Go for the reaction when you are doing. Okay. In this case also basically this 2. By mass, but if I give you this and you end up writing hydrogen 2 and you end up writing basicity 4, that is wrong. Not basicity 4. This dissociation reaction is what? Weak acid. So CH3COH. Organic acid. So plus H2O. What it will form? One hydronium ion and one lead ion. One will be lead ion. Not lead ion. Acetate ion. Acetate ion, right? Acetate ion. This is an acetate ion. This is an hydronium ion. So is it a polybasic acid? That is tetrabasic acid actually. Is it? It is not. So you have to see properly that what exactly is happening. Don't judge by the number of hydrogen atoms. Okay. Now comes tribasic acid. Okay. Tribasic acid means 3-step dissociation reaction. Okay. often common question, H3PO4 and H3PO3. H3PO4 is a tribasic acid. Now you will say this is also tribasic. No, this is a dibasic. Reason is very simple. H is bonded to O, that is fine. Bond energy is less, easily broken down. pH bond is very high. Okay, one hydrogen is bonded to phosphorus and that cannot be removed. One hydrogen is bonded to phosphorus, remaining two are with this. That can be removed easily. It is ionizable hydrogen atom. But here, this phosphorus bonded hydrogen is not going to get removed. So that is why, what will happen? In that case, what is going to happen is, this two will be removed, but one will remain. So it is a dibasic acid. It's a very important question. Okay, phosphorus acid is a dibasic acid. Give reason. Why? Because one hydrogen is bonded to the phosphorus atom and it cannot be replaced. Okay, reason clear? Okay. Now three-step dissociation reaction. I am just showing. H3PO4. First step, plus H2 added. What does it give? H3O positive plus. One H has been removed. So what does remain? H2PO4 minus. Okay? H3PO4 minus. Positive charge decreased. Second step, this will become the reactant. So H2PO4 minus plus H2O gives H3O positive plus HPO4 minus. How many minus? 2 minus. Why? One more H decreased. So what charge got now? 2 minus charge. Right? Last step, HPO4 2 minus plus H2O forms H3O positive plus. This hydrogen will also get removed. PO4 2 minus does not exist. So PO4 done. So ultimately we are getting this reaction. Now we can summarize this reaction at once, but if this is told to prove, then you have to show this three-step dissociation reaction. Clear? First step, H2PO4 minus is coming. Second step, HPO4 2 minus. Third step, PO4 3 minus. Directly summarize, then this will become 3, this will also become 3. Clear? This and this will not be there, this and this will also not be there, directly this will come. Clear? This is the three-step dissociation reaction. Now in this case, if I give instead of this NaOH, then what difference will come? Dot of difference will come. Okay? That you will be understanding when you do some numericals. Reactions. Let me say numericals. Reactions. So if I write instead of this will only change. That product side will change. Okay. So plus NaOH. So check, I have not balanced the reaction. So one Na will be replacing one H. How many will remain? 2. So what will be the formula? NaH2 PO4 plus H2. Understood? First dissociation reaction, product is this. What type of acid? Acid. Acid salt. What type of salt is this? Acid salt. What type of acid is this? Tribasic. What type of dissociation? First step dissociation. Let us go to a second step dissociation. Acha. What is the chemical name of this? Sodium dihydrogen phosphate. Clear? Sodium dihydrogen phosphate or monosodium dihydrogen phosphate. Same thing. Okay. Second step dissociation reaction is, if I add 2 influx of NaOH, 2 NaOH, then what will be the change? This 1H will disappear. So 2 Na, 1H, PO4. How many water? 2 water. Clear? So what change we see? 1H has decreased. Name has changed. Yes. What is now? Disodium hydrogen phosphate. Disodium hydrogen phosphate. Clear? So here also this remains same, but this differs. Acid salt is both, but formula differs. Name also differs. Third step I am not showing. This is the last step, final step. where we will put 3 over here, and this will become Na3PO4. Na3PO4, that is sodium phosphate, and that will be the third step dissociation. So to prove that phosphoric acid is a tribasic acid, 3 reactions are needed. Clear? 3 reactions needed is a dissociation reaction, not these reactions. Okay? Okay. Last part, that is a very small thing that you need to remember, that is tetrabasic acid. Name and tetrabasic acid might come as a question. Tetrabasic acid, so remember the acid H4SiO4. Okay, H4SiO4. It is called silicic acid. Spelling SiLicic, silicic acid. Okay, silicic acid is the acid which has got tetrabasicity, 4 basicity. This is basicity 4. It is tetrabasic. Okay, monobasic, dibasic, tribasic. This is tetrabasic. Clear? Now we just name polybasic acids 10 above 2 or more than 2. That is polybasic. Clear? Okay. Now let us move on to the next part, that is reactions of acids. Preparation of acids, whatever having, we will read that. Let me tell you something, that is your concentration. Concentration means how much acid is present in water. If acid is present in water more, then it is a concentrated acid. Vice versa is diluted. That is, water is more than acid. Often a common question is asked, that is, should we add water to acid or acid to water? We should add acid to water. Why? Because if we add water to acid, reaction will be very violent, might explode also. Highly exothermic, might explode. So what is done? Acid is added to water slightly and stirred continuously. Okay, it is added but it is continuously stirred. Stirring goes on continuously, otherwise there will be a problem. Okay. When do we see an acid to be weak acid? When degree of dissociation is less than 30%. Okay, dissociation is not there in the syllabus right now, but I am just saying. Okay, degree of dissociation is less than 30%, acid becomes weak. Degree of dissociation greater than 30%, acid becomes strong. Okay, this is the basic categorization we make, that is based on degree of dissociation. Degree of dissociation is number of acid molecules ionized by total number of acid molecules multiplied by 100. Not in the syllabus right now. So this is basically, just remember this thing, that degree of dissociation less than 30% weak, greater than 30% strong. Done. Now let us move on to the preparation of acids. How exactly can you prepare acids? Okay, preparation of acids. So to prepare acids, what can we do? Common sense says we can just put forward 2 elements and combine them to form it. Yes, we can do that. First part comes direct synthesis. Direct synthesis. That is called direct combination. You directly take 2 elements, combine them. That is direct combination. Okay. Direct combination like H2 plus Cl2. Both combine, form the HCl. Clear? Both combine, form the HCl. Well and good. This is direct synthesis. What type of acid? Binary acid. Why binary? 2 elements are there. So this is binary acid. Clear? Only binary acids can be prepared by this method. Okay? Any other acids will not be prepared. Binary acids can only be prepared by this method. Okay? Next is action of water. Very important. Mark it as very important. Action of water on non-metallic oxides. On non-metallic oxides. What do I mean, right? I am writing the reaction, we will understand. Action of H2O on non-metallic oxide. Suppose I write SO2 and I add water. What will happen? Common sense, H2 and 3O, SO3. Clear? So what is this acid? Sulfurous acid. Clear? So the action of H2 non-metallic oxide, what happens? This acid is SO3, H2SO4, P2O5, H3PO4, N2O5, HNO3. You have to remember this. Clear? H2O plus CO2 is H2CO3. Now the question often comes in a twisted way. What? Write the acid and hydride of this. Write the acid and hydride of H2SO3. Then what will you do? Subtract water from here. Subtract water from here. You will get the acid and hydride. Clear? I am just showing you. Suppose it has been told, find the acid anhydride of HNO3 and you don't know what to do. Finding the acid anhydride of this HNO3. Acid anhydride. Okay. Acid anhydride of HNO3. What will you do? Suppose you don't know anything. You have not read this part. What will you do? Simply you will subtract H2O. But if you see H is 1 and there is H2, you cannot subtract. So make this 2. How will you make this 2? Multiply the entire thing by 2. What will happen? H2N2O6. Now subtract H2O. Cancel. O remains 5 and 2. Required acid anhydride. Clear? So anhydride of HNO3 is what? N2O5. Nitrogen dioxide. Okay, it's actually nitrogen dioxide only, but we say it as nitrogen pentoxide. Okay, write pentoxide only. Dioxide will be going wrong because dioxide is NO2. Okay, NO2 is dioxide. So this nitrogen pentoxide. So nitrogen pentoxide is basically the acid anhydride of HNO3. How did we get? Subtracted H2O from the original part. Okay, next is oxidation of non-metals. Next is oxidation of non-metals. Okay, oxidation of non-metals. Third step is oxidation of non-metals. What do I mean? Suppose I write H, S plus HNO3. What will happen? You already know that HNO3 is a very strong oxidizing agent. We will come when we see the action of the hydrochloric, dilute acids on metals, and we'll see more. Okay, S plus HNO3. What will be formed? Acids will be formed, that is H2SO3. You check properly, there will be an acid formed, that is H2SO3. Sorry, not H2SO3, H2SO4. H2SO4, H2SO4. What else will be formed? Water, because it oxidizes hydrogen to water. And what else will be formed? NO2. Clear? So this is the reaction that you need to keep in your mind. Balancing I am not doing, okay? I am just giving the reaction. Balance you will do at home, okay? This is the reaction that you need to remember. Oxidation of this gives you acid, sulfuric acid plus water plus nitrogen dioxide. Clear? This step you have to follow for metals also, and you will do metals and also this concept will come. Okay. This is the third step, oxidation of non-metals. Second reaction will be going with phosphorus. Same. Okay, you can do it. Number 4. Number 4 is displacement. Double displacement that you have already learned. Okay, double displacement. This is a neutralization reaction. Clear? What will this form? Na2SO4 plus HCl. Clear? Double displacement you have read. Neutralization, precipitation. Right? This is not displacement reaction. Why? NaCl is not a base, it is a salt. Right? Okay. This is not a neutralization reaction, it is a double displacement reaction. Only double displacement reaction, not a neutralization reaction. Okay. So what is forming? HCl. Is it an acid? Yes, it is an acid. Clear? So this is how we are getting acids. Basic preparation of acids. Next is the properties of an acid. That I need not tell you anything. Acid property is very easy. It is sour in taste, corrosive action on skin. Then changes the color of indicator. This part is very important. Color changing indicator. Rest part I know you all can do it. Okay, but the indicator change part is important. Okay, I am discussing only the changing indicators. Rest I think you all can do it. It's very easy. So taste is there, then the corrosive effect on skin is there. Just you can do it. Okay. Next now is the indicator change. Hopefully everyone knows litmus. Color change everyone knows. It changes to red. Acid means red. Always acid means red. Okay. See, acid has got D, red has got D. So D will go with D. So red will be acid. Clear? If you cannot remember, check out. Acid has D, red has D, blue does not have D. Blue cannot be base. Clear? Blue cannot be acid. Clear? Second is methyl orange. Methyl orange. Methyl orange, you remember that methyl orange is pink in acidic medium. Clear? Original color is given in the question only. Orange changes to pink. Clear? Original color for litmus is purple, changes to red. Original color is given in the question. Orange changes to what? Pink. Changes to what? Pink. Acid changes to pink. Hint, word I. Acid has got I. Base has got I. No I. So it is not pink. Clear? Last one. Second last. Sorry, not last. Second last. Phenol pH phthalate. Many of you say it as phenolphthalein. It's fine. But spelling should not go wrong. If you write phenolphthalein, you may end up making a mistake, a blunder. So you can spell it as phenol pH phthalate. Clear? Phenol pH phthalate. So the spelling is absolutely correct. Phenol pH phthalate. Original color is colorless. Change in acidic media? No. No change. Colorless it was originally, remains colorless in acidic solution. So there is no change in phenol pH phthalate in case of acidic medium. Okay. Another one is there, that is called red cabbage extract. Red cabbage extract. Red cabbage extract. Color remains same as litmus. Red cabbage remains red in acidic solution. Red color remains red. Clear? It was originally red cabbage. Now it's also red in case of acidic medium. So these are the four indicators that you need to read. Another type of indicator as you mentioned in your book is olfactory indicator. Olfactory means something that changes its smell in acidic basic media. Clove oil. Okay? Clove oil, onion, this all smell can be changed. Clear? Okay. Acids are electrolytes, everyone knows that. Ionization happens. Okay. The last part of acid, let us read. The last part of acid is basically chemical property. Okay. Chemical property that I was telling. Chemical property. Okay. Chemical property we'll be reading is reaction with active metals. You already know metal activity series. So the metals which are located above hydrogen will only release hydrogen. Asked cannot? Yes. So what can, suppose I am writing zinc plus hydrogen chloride, what will happen? ZnCl2 displacement reaction, H2 release. Next, if I write Mg plus H2SO4, what will happen? No, don't write Mg. Zn plus H2SO4, what will happen? ZnSO4 plus H2. Accepted? Now, if I write Zn plus HNO3, will this reaction work? I am writing. Will this be a correct reaction? This is correct. Absolutely correct. Absolutely correct. This is wrong. This is wrong. Reason? HNO3 is a strong oxidizing agent. This hydrogen, it will oxidize to what? Water. So we are not going to get any hydrogen as the product. Instead we will be getting, this is okay, rewriting though, ZnNO3 whole 2 is okay. What else you are going to get? Water. What else you are going to get? NO2. Balancing you with these two. Okay? So now it is a correct reaction. So now hydrogen is not going to release by HNO3. Who can release? Two elements can release. One is magnesium, 1% dilute nitric acid, then it will release, and manganese. Two elements can only do exception. Manganese, magnesium, both can release hydrogen from nitric acid. Very dilute, 1% nitric acid. Clear? This is the basic thing. HNO3 you add, this will be you getting as a product nitrogen dioxide plus water plus the salt, respective salt, whatever it will be formed. Okay. Next, reaction with bases, neutralization reaction. I need not say what is a neutralization reaction now. Acid plus base gives salt plus water. That is a neutralization reaction. Clear? Next is action on salts. Action of acids on salts. This is where action of acids on reactive metals. Now, what happens if an acid reacts with a salt? Let us see. Suppose the salt taken is CaCO3. and we add HCl to it. Tell me what will happen. Ca will go for Cl, so it will become CaCl2. Remaining is H2CO3. Will H2CO3 remain H2CO3? No, it's very weak acid. What will happen? H2O plus CO2. You already know that H2CO3 is H2O plus CO2. So write down that. This is the answer. Clear? CaHCO3 whole 2. CaHCO3 whole 2 plus HCl. What will it form? Reaction more or less remains same. Right? Reaction more or less remains same. Clear? Balancing will be different, but reaction is more or less same. Clear? Calcium bicarbonate, calcium fluoride plus CO2 plus H2O. Clear? This is the basic thing. Clear? Okay. Next is reaction on sulfite and bisulfite. Reaction on sulfite and bisulfite. Reaction on sulfite and bisulfite. Okay, what is sulfite? SO3 2 minus. Bisulfite is some H SO3 minus. Clear? 2 minus. So SO3. Let us take this calcium sulfite. Add HCl to it. What will form? CaCl2. Common sense. What else? H2CO3. SO3. H2CO3. How is H2CO3 formed? H2O plus SO2. Right? So we will write H2. Clear? It will not stay at H2SO3 format. It will go to H2O plus SO2. This is how you have to remember. It's not possible for you to remember everything. In this case, you have to remember like this. Okay. Okay. Next is sulfide decomposition. Sulfide decomposition. If I write Zn plus HCl, you get sulfide na. Rotten XML will be used. Okay. Observation rotten XML. So what will be formed? ZnCl2 plus rotten XML gas H2S. Clear? This will escape. Clear? So H2S gas. Clear? Understood? So this is all that you need to remember from the acid part. This reaction is specifically more important. This reaction is specifically more important for you to remember. Okay, the observation, if any, you have to remember. Like here is rotten XML. Here no such observation is there. Okay. Observation, if asked, then you have to use some of your logic and answer. So this was all from my side from acids. In the next video, we will be discussing about bases. We will complete the complete topic about bases, and salts is a little bit portion, so that we will also try to complete in the base video. So hope you have enjoyed watching the video. Keep watching. Stay safe.